testing service. My name is Marilia Akureshima, and I will be your host for today. I will be also moderating the Q&A session. Next, please. Svein? Yeah. So let's start with some meeting principles. Today's webinar will be recorded and uploaded on various platforms. We'll be sending the recording, the Q&A, and the slides to everyone attending the webinar following our second webinar. That would be the 31st of January. I would like to ask everyone to turn off their camera and mute their microphone throughout the session. Please bear with us as we make this presentation interesting to everyone. You might find some of the material slightly advanced or technical or deep, but I encourage everyone to raise the questions in the Q&A chat or reach later to us through the registration webpage that you use to register yourself for the webinar. As we are recording the session, we will be taking the question at the end of the session. So please enter your question in the chat box, and we will make sure to answer all these questions if time allows by the end. If not, we will answer them and send them by email as well. Next, please. So I'm pleased to be able to present today's session with ENTSO-E. ENTSO-E has adopted the Common Information Model, an IEC standard, and developed a profile called CGMES to support the EU business processes. According to the European Network Code, TSOs, DSOs, and significant grid users have to exchange their own network model with the RSCs in order to run different use cases. But what we see is CGMES is not just an interest to the European TSOs and DSOs, but also to the global utilities. And more utilities around the world have been adopting CGMES for their own use cases. Therefore, application needs also to develop to be able to exchange CGMES profiles, and these new application needs to be conforming to the standard. Hence, why they need to be, this application needs also to pass the conformity assessment scheme, which is owned and maintained by ENTSO-E. On 17th of December, ENTSO-E announced its agreement with the DNV on providing CGMES conformity assessment service. The DNV will act as an assessment body, and ENTSO-E will remain the opinion body. Hence, together with ENTSO-E today, we put this series of webinars in order to introduce CGMES version 3 and its primary changes from CGMES 2.4 to 3.0. During the next webinar, we'll be introducing the conformity assessment schemes. So let's introduce today's speakers. Next. So as you know, my name is Marilia Akuri. I'm a senior consultant and a global service lead. I am a chartered engineer based in the UK. I have a 15 years experience working with utilities, and I'm also part of the IEC TC57 working group focusing on CIM. With me, I'm pleased to have with me Svein Olsen. Svein is the CGMES subgroup convener from ENTSO-E. Svein is a senior information architect. He works for Statnett, the Norwegian TSO. Svein has been involved with CIM since 2009, and he's also the member of the IEC TC57 Working Group 13 and 14, and the Smart Energy Working Group 6. With him today, I have Chavdar Ivanov. Chavdar is the marketing is a MD of Gridget Consulting, and also working for ENTSO-E. Chavdar is a senior consultant. He was a power system engineer with an MSc and PhD in power system. He has more than 20 years of experience with working with various utilities. He's been involved in CIM since 2007, and he's part of the IEC TC57 and TC88 focusing on the CIM standard. So without further ado, I give the word to you, Svein.
Thank you very much, Marilyn. So the plan here is to go a little bit quick through why the CGMES was developed, a little bit from the ENTSO-E point of view, and then I'll go into the the core of the CGMS and a little bit explain what's the difference in the two standard documents. So the idea of having webinars is we kind of continuing the set of webinars. In 2020, we had 3 webinars where we looked into the development of the CGMS standard, where we got feedbacks from utilities and vendors that was incorporated in addition to the whole standardization process. And those webinars are available. Some of them, the 2 last one, is available on the net. We also had 3 webinars in regards to the conformity assessment scheme, where we also took in some of the changes that was done in CGMS 3 in the beginning of 2021. And as Marilyn introduced, we're doing 2 webinars now to kind of summarize the conclusion and give a little bit introduction, and preferably we are focusing on the conformance assessment schemes, that we go in detail in the next webinar. So ENTSO-E has a CIM expert group that has kind of the responsibility of, if we look at the SCAM, the market, enterprise, and operation. There is a liaison between ENTSO-E and TC 57, the working group 13 and 14 and 16, that is all developing the same standards. And we are trying to make sure that all of these standards interact and give advice to the different processing groups at ENTSO-E. And today there's multiple processes that use CIM, and there's also multiple processing using CGMS, preferably the common grid model process that's dealing with system operation. And we also have the 10 years network development planning. And the development of CGMES 3.0 is part of the CGMES Roadmap that was being approved by the System Operation Committee. This is publicly available, you can download. And in this, we kind of trying to build up the scope for the consolidation and also the upcoming CGMS functionality. In principle, we outline 5 releases. This will be a little bit modified in the upcoming roadmap, but the functionality is still there, but the way we are packaging a little bit different. Because as we work with consolidated, we realized that we also needed to address some of the urgent items in the other blocks. So these areas we consider fully covered by CGMES 3. There is some area in regards to HVDC, particularly with operation planning, that we still have slightly issues with, but in general, all of this is covered. In addition, we haven't gone deep into making sure all the requirements are taken care of all this different area, but the requirement that we knew of has been addressed in CGMS. And I would then highlighting that we have made modification to the CGMS previous standard and to this one to have better harmonization with TSO, between TSO and DSO. So they'll introduce quite a bit of items that is relevant for DSOs. The whole concept as well is that we have a set of building blocks, and we try to make it such that we can extend on the CGMES 3.0 to deal with additional requirement to fulfill the roadmap. So what we've done in this release is fixing the inner workings to address the needs that we have discovered through the usage of the CGMES. So the main focus of these changes, there have been some technical, but a major one that we focus on is to satisfy the business needs. The CGMS 2.4 has been used since 2014 in the long-term term development planning, and and also as outlined for the network codes. We have also, as now in the CGMES process, are live now with all the TSOs to exchange the CGMES process. So the issues that we have discovered through the implementation for both the CGM process and the 10 years network development, in other words, the system operation planning, and the system development planning or the long-term planning. So the requirement in the inner working, that doesn't mean that we have met all the requirements, but the one that is interfering with the inner working is being addressed. There is no major new functionality in the CGMES, but it's quite a bit of fixes that Chowder is going to be taking out in the second part. So first, I would just want to make sure that we have a little bit common understanding what is included in the CGMES 3.0. What we are really trying to address with the Common Grid Model Exchange Standard is the data underlying for power flow. And what we are looking at is we have an as-built network construction part that describes how the network is. And we are also trying to separate into different profiles so that you don't need to have one system that can cover everything, but you can have multiple systems contributing to a common process. And also the idea that the same data can be reused in multiple processes. So we're trying to avoid any point-to-point exchanges, but more the idea of having a shared data set that can be used by multiple tools and multiple processes. And not at least we're trying to address the needs to exchanging data between utilities, both on the horizontal layers, in a way could be TSO, and the vertical layer where we need to address between TSO, DSO, and for these, in Europe, we also have the RSC or the ISO, and then also all the way down to the system grid operators, the generators, the significant loads. So that is kind of the aim, and then we have a full common model. We have a line where how we're going to do with dealing with plant construction, because when we're dealing with long-term planning, we are also looking into the future. And we're having a description of this that is in principle persistent in a way. Yes, persistent for the as-built, but has some control change mechanism in regards to plant tooling. Then you have your network operation practice. You deal with plant maintenance, you have your force unavailability, and of course a lot of dealing with weather condition. These goes into some way of device status initialization and also some control setting initialization and also what you need to monitor. In addition, you have the energy allocation to device. So when you're having, particularly looking into the future, you have plans or forecast or a given scenario that you're going to be testing for the long term. You're dealing with measurements when you're in the real-time system. And this needs to be an energy injection utilization. So the concept of the equipment model and being a more persistent part and a version through time is then exchanged through the equipment profile. Then the input to the power flow called steady state hypothesis is giving you all the setting, all the energy injection, which is your starting position for your power flow. This goes into a topology processing where you are distinguishing how the topology are based on the connectivity that is given by the equipment model and the steady state that tells you what type of breakers that is connected and not. And that gives you the topology, and this topology can also be then exchanged in a topology file, instance file. And it is also used as the input of power flow, and the result of the power flow is then exchanged in the state variable SV file. So this is the core understanding of the CGM. We have additional profile that is supporting this process, but also giving more a human readable look at things. I will go through those. The primary use cases are two. One is the node breaker that can be, you know, either actually a power flow for the whole node breaker, but typically the result from a state estimator. The concept is that you have your net equipment model defined in the EQ. You get your topology, network topology process. You get update to your schedule data, and this goes into the state estimator together with the analog and the discrete value. The discrete value being, for instance, the breaker being open or closed. This gives you an output for what all the settings in the system through the state estimator, and then all the result of the state variables that you have given through the power flow or the state estimator in this case. The second primary use case is the bus branch power flow, where you basically have your equipment model, and then you have a case build that gives you what you have your input to your power flow through the steady state or processing. That you have a network model builder that's producing the topology process. Both of these can then be exchanged, and then you have the power flow providing you the state estimator. One of the big challenge we had in the CGMES building is to be able to accommodate from both sides of this, meaning that they are looking more and more on the planning side to have a node breaker model, but you don't necessarily produce a node breaker model for your forecast because you're just investigating. You don't necessarily have all the detail, but a little bit depending on where you are in the time horizons. So one of the big challenge was to get a good way of describing a hybrid. So CIM has been long time been able to address both of them, but not really well addressing both of them at the same time or in the same model. So those are the things that we have been addressing. Part one is describing the structure and the rules, particularly focusing on that you have a series of exchanges that is giving the process owner advices. That doesn't mean that there's still some room for specific processes, meaning that we have some process for the CGM process in Europe. We also have other processes for the 10 years network development planning. Both of them are relying on the same standard, but may have some additional constraints. This means that it could be adapted all over the world, other places. And the reason we want to make it like that is that we have more tool vendors supporting the same standard, so that we have better choices as utilities and also a better investment in the tooling. Part two is addressing the profiles. In part two here, we don't have an elaborate description about the profiling, but we're describing each of the profile. And in this work, we have aligned it with all the 450 series. We are planning to extend it with more information model. Currently, the extension that we have in the CGMES, that's not part of the 450 series, is part of the 301. But there could be that is additional extension. We also, if the additional profile is specified, that is also planned. And we are also on the long horizon planning to make the conformity assessment schemes part of the standard. Currently, those are specifications created by ENTSO-E to tell how the different standards should be tested. So primarily, we made a little bit extension in regard to core equipment. In the 450 series, we don't really have an equipment boundary. So what we have done is we put that as deprecated. We're planning to have that anything being in the core equipment and also other element that is persistent through time can be declared as a common element between two parties. We have a short circuit that is extending the core, and we have the operation that is also extending the core. So the operation would have elements in regards to the operation. However, this has become a very small profile from previous version. So primarily everything is in the core equipment, but anything dealing with short circuit has been extended. In some cases, there's just attributes to the existing equipment. And in addition, we have the TP, we have the state variables. We also published the diagram layout, and the diagram layout is the only one that has not been aligned with an updated 453, but it is minor changes that has been done to the layout. The dynamics is included, and also the geographical layout. So all of those profiles are described, and all of them are tagged to be in the EU domain. So this is then showing a bit of the dependency. And the plan is that the 600-2, when we're looking at the alignment, will only have the extension on the equipment, and there is also some extension in regards to the geographical location, some ruling. Then all of the other profiles are aligned with the new standard that has been published, the part 13, so 61968-13, which is the CDPSM, that's the standard for the distribution. We have the 457 describing the dynamics, and that is now fully aligned with the power flow, the equipment. We have the 452 that is aligned with the core equipment and short circuit and operation. And the 456 that was actually published, I think around 12th of December. So all of these, and these documents will provide even more detail in the different domain or areas. Then we have a dependency on these different files, and the core one is the core equipment. We still have this optional dependency on the boundary, that is meaning common reference data and also common bilateral data. The short circuit operational cannot be changed as separate. Be also aware that you can put them together as you have one instance file that fits for all of them. And you just tag the instance file that you do support all of them. So if you have one tool that can operate all of them, then you just can have one instance file. But if this has been done in separate system, then you can have a separate instance file. From this, we can extend it with the diagram layout. We also extend it with the dynamic models and the steady state, and the reference, so the topology is referring to the EQ through the reference of the steady state. The steady state is exchange per situation, meaning that in Europe that you have for 1 hour, then is exchange 24 during one common day. And then the same thing with the state variables referring to topology that refers to the SSH and refers to equipment. So CGMES is the fundamental to support the power flow. This gives the business capacity, which could be different processes, but using the same standard exchange for system developing, like long-term planning, and system operation, which is operation planning. In ENTSO-E, we are doing that up to 2 hours before the operation, and from year ahead and up to the 2 hours in front of the operation. In addition, we also use it to exchange the snapshot as built, the snapshot of the situation at any given time. This is then used for, of course, the steady state power flow and on the short circuit analysis. There is, the result of the short circuit is something that we are planning to extend the standard to deal with, and it also can support transient stability analysis with a whole range of models that is also aligned with IEEE, and then you can have power flow analytics tools, and it can also be the basis for any security assessment or continuous. Give it over to Chowdhury.
Thank you, Sven. So first of all, good afternoon, good morning, or good evening for all of you around the world. I see we have quite a good audience here. So I will be telling you a little bit more on the changes between CGMES 2.4 and 3. So now that you know all the basics, we are going to step further into the details and all the effort that has been done between 2013, 2014, and 2021. So we can go to the next slide. So this one, I want to present you where to find the information on the changes. So we have at least two places where you can look at. So the first one and the most official one is in the Annex A of the 61970-600-2. In that annex, which is quite extensive, you will see information of the level of different changes. Is it a high, moderate, or low level of impact? This is, of course, very objective, so you need to read it with your eyes and depending on how you implement your software. Then another alternative to use is to rely on the RDFS. So we published together with the conformity schema all these RDFS for CGMES 3, and you have also the schemas for CGMES 2.4. You can use an open tool, SimPower, to compare those RDFS, and you will get an Excel file with the difference, which then you need to filter and analyze. So that's it, another option. So if you go further. So with this slide, I want to draw your attention on the implementation, because over the years we see different approaches and we want to be sure that the right approach is taken moving forward. So the first important thing is don't really rely only on the list of changes to implement. So be aware that especially the Annex A in the standard may not be fully complete and you may miss something. So you need to rely on the main part of the specification. The second important thing is that you shouldn't implement the standard looking at the test data and all these sample snippets that are published here and there. So this is important to look and to see what are the potential ways to exchange, but it's by no means complete. So we really see over the years that people come to the real exchange and say, I saw it like that in the test data and I didn't do more than that. So that's not really good. Another point is to look really in detail on the rules and constraints that are published in part 2. In the foreword of that standard, there is a small list, half a page or so, which will guide you on the on the changes, and quite a few of the rules were modified or simplified, and a lot were deleted. Then the other important part to look is in the clause 16, in the second part, which gathers all the profile constraints across all the profiles. You need to know that that's basically the only place where you will find the English expression of the rules. We do have machine readable equivalent of this into the Shackle application profiles that we published from ENTSO-E. Another important thing is to know that in other sections of part 2, there's no additional information compared to what you will see in the machine readable artifacts. So this is the listing of the attributes, associations, and their descriptions. So don't look for additional information if you already processed the machine readable. So you need to pay attention on annexes. For example, Annex B is giving you clarification on the reactive capability curves. There is a special rule, this MVAL5, also in, I think there's a mistake here, it's in the -1, which explains how to instantiate attributes in SSH for the classes that are not included in that profile. So that's something that was not fully used in CGMES 2.4, and you need to see how this should be done in CGMES 3. Another important moment is that the header is advisable to implement it in a flexible way because some changes are expected and the applications needs to be flexible in that area moving forward. If we go to the next slide. Now this one illustrates the changes in numbers. As you see there, different categories. We didn't record the changes of height impact, but we have some with moderate and quite a few with low or no impact. No impact changes are the one that mostly editorial, and the one that were considered that might have some impact were categorized between the low and moderate. And if we look at the next slide, this also visualize a bit what we have integrated in the CGMES 3. There is the starting point was 2.4.15, but there were many implementation guides and quality rules documents, issue resolutions, which were not implemented in the last years. So you have to see CGMES 3 as a service pack of CGMES 2.4.15. We tried to be as much as possible backwards compatible, especially on functional level. So there's no new profiles or new types of exchanges, but it's many issues are fixed. And depending on implementation on software side, that could cause low or moderate impact. If we go further, so here we have a list in the next 2-3 slides of some of the changes that we want to highlight. So the first one here is the ability to exchange hybrid models of node breaker and bus branch. In the CGMES 2.4, that was not fully qualified. And now we integrated the connectivity nodes directly in the equipment core profile, which enabled to have a mixture between node breaker and bus branch modeling styles. There were many issues related to boundary, and those were fixed in CGMES 3. together with what also Sven said, that we marked the equipment boundary profile as deprecated, and we rely on the future on the main equipment, the core equipment, playing the role of boundary. At the moment, there is a complete match between the two profiles, with the exception that, of course, equipment core profile contains much more classes. Another very important thing to mention is the rules around the containment. So there's no other document that qualifies this really to that extent. We have plenty of rules and terms into -2 of the standard, which really in details goes to prescribe what the containment or what allowed containment should be. The other two here on the list are related, so one to HVDC, where a lot of descriptions and constraints were fixed. And in general, CGMES 3 has a lot of sign conventions and value range constraints added, because many of the problems we saw in the last years, they were actually rediscovered because things were not fixed in the main specification. And maybe here it's time to draw your attention on two important things. So try, when you implement your software, to do it as flexible as possible, because things like that will need to be immediately implemented in the main specification. And what the utilities require is to have fast implementation of those new requirements and new specifications. So we have short time going to market. So we know many requirements are coming, and if we have 3 to 5 years to move from one version to another, this will never work, and the business processes will invent other means of exchange which will disturb the interoperability. So that's also one of the lessons learned, that make sure that you have more model-driven implementation and you are able to supply new versions as soon as possible. If we go to the next slide. Yeah, so dynamics profile was already mentioned. So this is included in the CGMES 3, and at the same time, this is published in the 61970-457 standard last year. There were fixes related to the wind models and other elements in this profile. We have also significantly clarified the things around the operational limits, and there will be even more changes coming further, but this was considered necessary for the time being. Disconnecting circuit breaker was added, and that was due to some of the network code requirements. And by the way, all those things that I'm referring now here as the changes, they are also part of CIM 17. We try to align as much as possible CGMS to CIM 17, and over time we will have also the extensions included. So the modeling of the T-line was clarified, and additional few types were added based on the network code requirements. And I think on the last slide of changes, if I'm not mistaken, there is a few other to highlight. Yes, that's one relates also to the operational limits, where there was one requirement there to add additional enumerated values. We have clarified also the regulating control. Some of the attributes were not used correctly, and that was now clarified by the descriptions. The power electronics classes were added. In CIM 16 there is a gap, and now this is fixed in CIM 17. Another important element is the in-service flags on the equipment and the SV status. So these are also used now in the CGMES 3 and also in the 400 series of standards. And last on the list, we have the application profiles. So the RDFS was improved. There were some syntax errors in the exports compared to the previous schemas published for CGMES 2.4, and shackle constraints were added to the package. So moving forward, the idea is that the RDFS represents the vocabulary and the shackle represents the constraints. I think that's all from my side, and now we can open for questions. Marily, you can take it over.
Yeah, sure. Thank you, Svein and Chafta. This was quite interesting. We have a couple of questions actually in the chat box, which we were trying to answer. But maybe we can go through some of them as well. One of them is CGMES version 3 is designed to be applied for distribution system or only bulk power system transmission and generation. I think that's for you, Svein.
Yeah, so what we've done now is we have added things like feeder. We have added some other elements, also like the power electronics, that should be compliant or very helpful for distribution. There is items that like usage point to customer. So when you really go down to low level, what we are planning then is to make sure that we have a well-described alignment with the CDC, the distribution profiles, which is the part the 61968-13. Which we're already using their standard for geographical. So we're not trying to develop that. The other thing that we are that is a little bit crucial is the boundary, and that's one of the reasons we have make changes to the boundary, because in transmission the primary boundary is on tie lines, but between TSO and DSO, or for that matter DSO and DSO, that the boundary is many times inside the substation. So we are planning to have an upcoming spec to deal with that part.
Thank you, Svein. Another interesting question related to the distribution grid as well, saying that they want to exchange distribution grid using including all grid from high, medium to low voltage, and including substation equipment all the way to the user and user to the meter. Can they use CGMES version 3, or they were wondering what's missing in terms of exchange of data?
You should definitely start with the CGMES 3, because as I said, we have feeder in there. We also have power electronics for dealing with batteries, and we also have auxiliary equipment. So there's a lot of things that we've done there. However, there is not a profile for a usage point in the CIM, but the idea is to align that with the distribution part 13 profiles.
Thank you. And then the next question is about SSTI studies. So SSTI studies stand for subsynchronous torsional interaction. Is this included in the -457 standard, Jaftar?
Yeah, we have elements on that, but this might not be fully completed. So there is now a new version coming for 457. And down the line, I think it would be also included in the package of the CGMES. But in general, that version is still lacking of controls related to HVDC. I see here mentioned in the comments also the interaction between the generator, turbines, and power electronics HVDC. So that's an area where the modeling and the controls of the power electronics and HVDC needs to be further developed. But some parts can be used as an input.
Thank you, Chafdar. We have another question about the EQBD. So will the EQBD definitely be deprecated, or is it really related to the TPBD?
Yes, so maybe here maybe something we forgot to mention, the topology boundary is actually not included anymore in the CGMES 3, and the equipment boundary is deprecated. So it still can be used, but the idea of deprecation means that in the next releases we expect to not include it.
Yeah, thank
Sven,
you.
if you want to complete.
Yeah, no, it's correct. So it's kept there for backwards compatibility and to make sure that we move forward. The TP is being replaced, so there is no need to support that in 3.0 because we included the relevant information in the EQ.
Yeah, and maybe something to complete related to that. One reason of removing the TP boundary is because currently the main TP, as well as the ASV, are considered the pure output. So that's important also to realize with the inclusion of the connectivity nodes in the equipment model, especially for the boundary points, there is no way how we can predefine the boundary topological node. So this is why it's one of the reasons why we removed the TPBD, and we have one TP file across all the model authority sets included in a CGM.
And again, particularly when you're dealing with TSO, DSO, where you have the boundary inside the substation, then it becomes totally impossible to predict or have a fixed way of dealing with topology. So, and then it's better having one way of solving it for transmission and distribution.
I think we have a follow-up question actually on this. So the intention is to eventually phase out the boundary data set altogether?
Yeah, not the data set, but the profiles. So the profiles, meaning that in principle, any data that is shared between common utility can then be considered a boundary. So it's a little bit different way of thinking it, and we don't want to have a specific constraint in that area. That's we struggled quite a lot to deal with it, because the end of it, where do we put the line, what you can agree on? Okay,
thank you, Svein. And then I go next to the question. I think here they meant the significant grid users. So when are they expected to comply with the CGMES?
Yeah, I mean, I saw also some talking about when the different processes. So we in this, we're primarily looking at the standard. There are different organizations in ENTSO-E that is dealing with when things are implemented and when things are effect. And also the idea with the significant grid user is also a stronger national lead on it that you can apply. But clearly we see the whole range coming downwards, and what we're trying to do is finding a good common concept. So any tool vendor that deals with transmission can also deal with at least part of the distribution, they can easily extend it to deal with, and the same goes the other direction. But when people are needing to do it, because you can have national flows and depending on all the different implementation. So that's a little bit outside the scope of the standard itself.
Okay, thank you. More and more asking about the roadmap on when things could happen, etc. So I think you touched a bit on it. And then I have a question here. Are there already plans by when CGMES 3 should be used by ENTSO-E, for example, for TOI, the long-term development process?
Yes, as I a little bit said, we are primarily in the group making sure that we have standard that's fit for purpose, and it's up to the different process owner to say. But there is clear in the, there's a clear message that we are moving forward to the CGMES 3.0, both for the CGMM common grid model process and also for the 10 years network development process. But it is also what we want to see is how many people are signing up to do the conformance. If we have a good turnout for tools, and if it's less, then we need to, the utility needs to support it. So it's and all of this is actually decided by the community, so every TSO has a way of saying it. So it's a quite complicated process to say when we are relying on, but it is definitely the intention. We are making it because we want to do this.
And maybe it's important to state that it's actually the requirements that drive the development of the CGMS. So there's definitely a need from the TSOs to go for it. And it's a matter of how quick this will happen. And that's depends a little bit on vendors, how quickly they can implement, and the quicker the better. So
yeah, and the fair is a little bit that you have some on the side exchanges that doesn't really fit in, and then you have a lot of different for each of these process, and that's what we are trying, and we get rid of quite a lot going from 2.4 to 3. And we are trying in our roadmap to try to get rid of this. But each TSO or each region has a different speed. Like for instance, the Nordic has a higher speed in regards to dynamics. And so it's hard to make sure that everybody's a contention. The same also go with HVDC. There's quite a lot of TSO that doesn't care much about the HVDC, but the one that cares a lot. So.
Maybe there's a question, Sven, on the which processes rely. So maybe that one.
So which European processes is relying on CGMES?
Yeah, so right now we have the 10 years network development planning, which is a process that's bi-yearly, but it's going more also on the kind of yearly, where you're looking at the scenario for 10 years into the future. So you're looking what type of changes, and you run the different types of study on that. So that is one key process. Then the other process is the system operating process, where you're looking in from a year ahead. So what is the plan for the year ahead going forward, and down to 2 hours before the real-time operation, and also a snapshot of real-time operation. So the CGMS, and then not all of the process, because the CGM is one key of creating a common grid model. Then on top of this, you're going to do adequacy study, you're going to do outage planning, and you're going to do security assessment, and you're going to do capacity assessment. And we are looking at expanding the vocabulary to deal with all of this.
It's just at the hours. I think we'll take the last question. Are the DSOs smart grid user going to participate in ENTSO-E CIM expert group to improve extend CGMES?
Ooh, that was a difficult question. I think that's not really a standard question. That's a more organizational question. So I don't want to say anything except that this has been worked on. There is a project called One Net that is also trying to deal with it, and we have the establishment of the DSO, or the new organization. How we interact and work on this, that's is hard to say, but in general we are business driven, so there is the idea of coming up with common rules, and that's what happened now. And the green energy build is also focusing all the way to the usage point. So there's a lot of interesting work ahead, and I'm encouraging both the utility to be aware of this that's coming when they're looking at their application strategy, and I definitely want to see that, you know, that there is a challenge. You know, do you want to go for one tool that can do everything, or do you want to distribute this? And the more you want to distribute, the more you need to be totally aware of the CGMES and the associated CIM standard that can support you. And in the same way, I would encourage all tool vendors to be aware that, you know, there is opportunity here and there is also threat, in a way that is I'd be very surprised if this hasn't got a big attention. I think with the energy prices in Europe going up, there is an extreme focus, and the vendors and the utility that is not keeping up with it will get challenged.
Thank you, Svein. We have quite more question coming, but I would suggest that we close for today. We will be answering all the questions by a follow-up email. We will take all your questions, provide the answers. We will be also sending the recording and the presentation following the second webinar. I would like to thank you, our speakers, Svein and Tjaftar, for today, for a very interesting session, and all the participants for interesting question as well. And see you next week. Same timing from 3 to 4 CET time. Thank you very much.
Thank you. Bye.
Thank you. Bye-bye.
Bye.